What's up, you freaking geniuses? So in this video, I'm going to teach you how to express intervals in set builder notation and also show you how to graph them on a number line, all right? So set builder notation basically is going to look something like this. So the way that you read this is some set, so we'll just call it set A, is the set of all x's such that, and then you just kind of explain your conditions here using inequalities. Okay, so that probably sounds really vague and weird, but I promise you, once we do a few examples, it's going to start making way more sense. Okay, so let's start with this example. So we have two parentheses, right? And then we have a 1 and a 5 on the inside, all right? So this interval goes from 1 to 5, and again, we have two parentheses on the outside. So this interval, we're going to say is equal to, and then we're going to write our braces right here. So we're going to put the braces right there. And we're going to say that this interval is equal to the set of all x's, right? So we're going to put our x right there, such that, so let's draw our line, such that, and then we're going to describe the conditions of this interval right here in this empty space. Okay, and the way that you do that is you use the two numbers that you're given. So here we're given a 1 and a 5, right? So we're going to draw in a 1 and a 5. And then in the middle, between the 1 and the 5, or the two numbers that you're given, you're going to put an x. Okay, now we have to put inequality symbols between the numbers and the x. So we have to put one here and here. Now, the way you figure out what inequality symbols to use is by looking at the end conditions of your interval, all right? So here you can see we have parentheses. So whenever you're given parentheses, you use a less than symbol. Okay, so we're given two parentheses, so we're going to use two less than symbols. Now, on the other hand, skipping ahead a little bit, if you're given a bracket, you would use less than or equal to symbols. Okay, so that's the only little difference that we're going to have to look out down the road. Okay, so now as you can see, we have a compound inequality, right? We have x is greater than 1 and x is less than 5. So this is the thing that we have to graph on a number line. So let's draw out a number line right here. And then the limits of our number line are from 1 to 5, right? So let's label those points. So we'll put 1 here and 5 there. And now let's put the symbols on. So here you can see on the interval we have parentheses, right? A parenthesis around the 1 and a parenthesis around the 5. So here we're going to do the same thing. We're going to put a parenthesis around the 1 and a parenthesis around the 5. And then you're simply going to shade the space in between your two limits right there. Okay, now one last thing that I want to mention here is instead of parentheses, sometimes you might use open circles. Okay, using parentheses or open circles basically means the exact same thing, and you would do the same thing right here, just shade the space in between. Okay, so both methods would be correct, but in this case, I'm just going to stick to using the parentheses for now. All right, so there's our graph, and there's our interval in set builder notation. All right, now the next interval that we want to write in set builder notation is this one right here. So this one goes from -1 to 4, but notice we have a parenthesis on one side and a bracket on the other side, okay? But again, we're going to start with the exact same steps. So we're going to say that this interval is equal to the set of all x's such that, and then again, we're going to have a compound inequality here, and then we're going to close our braces right there, okay? So again, use the two numbers as your limits. So we're going to say -1 and +4. And then we're going to put an x in the middle. And then we just have to put our two inequalities right there, right? So as you can see, we have a parenthesis around the -1. So that means we're going to have a less than symbol. And we have a bracket around the 4. So that means we're going to have a less than or equal to symbol. Okay, so again, parentheses, you just have a less than symbol, and brackets, you have a less than or equal to symbol. Okay, so we have our compound inequality right here. So now let's graph that bad boy on a number line, and our limits are from -1 to 4, right? So -1 and +4. And we have a parenthesis around -1, so we'll put in parenthesis there. And we have a bracket around +4, so we'll put a bracket on +4, and then again, just shade the space in between. Okay, and again, if you were using circles, you could draw an open circle right here over -1, and a closed circle around positive 4 and shade the space in between, right? Either way works just fine. All right, now the next interval that we're going to write in set builder notation is this one right here. So 1.5 to 6, and they have 2 brackets around the ends, right? So we're going to say that this interval is equal to the set of all elements x such that, and then we're going to write our interval right there, and then close our braces. Okay, so the 2 numbers for our limits are 1.5 and 6, right? So 1.5 and 6, and then we're going to have an x in the middle. And then here you can see we have 2 brackets around the ends, so that means we're going to use less than or equal to, right? Less than or equal to on both of them. All right, so now the last thing we have to do is just graph this guy on a number line. So then our numbers are 1.5 and 6. And then we have 2 brackets, right? Or 2 closed circles, whatever you want to do. And then just shade the space in between there. Boom. All right, so here, this is going to be a little bit different now because as you can see, we have an infinity symbol, right? So we're going to start at the exact same spot though. So we're going to say that this interval from 2 to infinity, positive infinity, as you can see, has 2 parentheses around the ends, right? So we're going to say that this interval is equal to the set of all x's such that, and then here again goes our inequality, and then we're going to close our braces, all right? So here, as you can see, where the interval goes from 2 to infinity. So for our interval, we have to say that all the x values have to be bigger than positive 2, right? Because here, again, the interval, the smallest number on this interval is a positive 2, and then it goes all the way to positive infinity, right? So here we have to say that all the x values have to be bigger than positive 2, all right? So now in order to graph this on a number line, it's not going to be too bad. Let's draw our number line right there. And then we have a positive 2. Let's write that guy right there. And then we're saying that all the numbers, all x's have to be bigger than positive 2, right? So they go off into this direction towards positive infinity. Okay, and notice there's a parenthesis around the positive 2. So we're going to put a parenthesis right here. Or again, you could put an open circle if you wanted to. All right, now the next interval that we want to write in set builder notation is this one right here. So it's negative infinity to positive 3. And we have a parenthesis around negative infinity and a bracket around positive 3. Okay, so we're going to say that this interval is equal to the set of all x's such that, and then we're going to put our inequality right there, and then we're going to close our braces. All right. So looking at this interval, you can see that this one is going towards negative infinity, right? So the biggest number in this interval is 3, and then it's going down towards negative infinity. So here, for the inequality, we're going to say that all the x values have to be smaller than positive 3. Okay, and notice there's a bracket around the positive 3, so that means we have to use a less than or equal to symbol. Okay, so all the x values have to be less than or equal to positive 3. All right, so if we graph that on a number line, we're going to have a positive 3 right there, and then they're all going to head down towards this direction towards negative infinity, right? And then again, we have a bracket around 3, so you can put a bracket right there at 3, or again, a closed circle. All right, so here's the last example that we're going to go over. So this one goes from negative infinity to positive infinity, all right? So again, let's just start at the beginning. So we're going to say that this interval is equal to the set of all x's such that, and then our inequality goes here, and let's close our braces. Okay, now in this scenario, we're actually not going to have an inequality because as you can see, there's no restriction to what x can be equal to, right? There's no limit. X can be any number, right? Because the interval goes from negative infinity to positive infinity. So since x can be literally any number, here we're just going to say that x is a real number. All right, so if we graph that on a number line, here in the middle, let's just put a 0, just for a little perspective. X can be any number. So you would simply shade the entire number line in both directions. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.